Today we are taking a look at congruent triangles, chapter 13, page 132. So the two concepts we mostly look at is congruency and similarity. So it's congruent triangles or similar triangles. And I'm just going to help you to not get the two confused. So when we look at congruent triangles, it's when we have two triangles that looks exactly the same, but the one is slightly bigger or smaller than the other. You see, it's exactly the same triangle that I took, but it's bigger or smaller. That is congruent. When we have a triangle that's exactly the same, but the other one is just in a different position, so maybe turned a little to this side, like that. Do you know it's exactly the same triangle, just on another side? This is similar angles. So congruency, bigger and smaller, similar on a different triangle. Now, when we state our cases for congruency or similarity, we have different rules that we apply. So we're going to look at congruency today, and we will look at similar triangles tomorrow. Our first case of congruency is when we have two triangles and all three the sides are the same length. In this picture, it's indicated by color, but if there was no color, you could also go with the lines, because one line, two lines, three lines, indicate that they are exactly the same size. So when we have three sides that's exactly the same, the two triangles are congruent. And we will write this with a reason, the same way we write Pythagoras as a reason, or opposite angles, or things like that. We also write reasons with congruency. So for our first case, the reason is side, 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 because all three sides are similar. And we write it like this: S, S, S. Side, side, side. Our second case of congruency is side, angle, side. Okay, and we are working in two triangles. So the first triangle that we are working in is A, B, C. So it's this green one. The second one is ABD. A, B, D. That means it's this whole triangle. Now, which side do we find in both of them? We find that C is in both of them, but for ABD, C is in the middle. But then they also tell us that AC is equal to AD. So we know if our triangle ABC have this side, it is equal to the same as AD in our triangle ABD. So that is our first side. Then we need an angle that's in both triangles. And we can easily see 25 because it's part of this triangle and it's part of that triangle. And the last side is AB because it's a common one. It is part of this triangle and it's part of that triangle. So let's have a look. We have this side that's in both. We have this angle that's in both. And we have this side that's in both. So our second case would be side, angle, side. This can also look different when the two triangles are not part of each other. Okay, so we can have two triangles like this. And you can see again the one line or the blue indicates they're the same. The green and then the red doesn't have a line through, so we don't know it. But the angles are also given as the same. So again, we can prove that these two are congruent because side, angle, side. So the two triangles can be in each other or they can be separate. Now, our third case of congruency is angle, angle, side, when we have two angles and a side. Now, let's have a look here at our picture. In each one of them, we see there's a 98-degree angle, and in each one of them, we see there's a 45-degree angle. Automatically, that leaves the third one to 37. But that means we have two angles, and now we're looking for a side. And we can see this blue one with this line indicated in all three tells us each one of them has the same length side there. So we have angle, angle, side. And that is our third case of congruency. Angle, angle, side. And our fourth case that we will be looking at is the right angle, hypotenuse, side. Right angle, hypotenuse, side. This is how you will write your reason. So the first thing we need in both triangles is a right angle, 90-degree angle. Then hypotenuse, and one side that is equal to each other, indicated here by the red. Okay, so often when we are working in these, we first use Pythagoras to work out the sides, and then we find that the two sides are similar, and we have right angle, hypotenuse, side. So let's just quickly recap. The 4 reasons we have to prove that two triangles are congruent, meaning bigger or smaller but almost the same, is side, 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 when 3 pairs of sides are the same. Side, angle, side, when we have 2 sides and an angle in between that is equal. Angle, angle, side, when we have 2 angles and a side. And right angle, hypotenuse, side. Okay, so now you can go to your book, have a look every time they give you 2 triangles, and you have to prove why they are congruent by using one of these 4.